Sample space diagrams, part 2. Okay, we're going to do one question here. Actually, for your questions on Heggerty Maths, you can just use this diagram again to answer the questions rather than having to draw it all out again yourself. Roll 2 fair dice and add the results. The key word here, and this is where it could catch you, is it's saying add the results. Yeah, rather than just state the results. Probability of getting, and you have to work out all the things. So when you have things like adding results, you have to do a sample space diagram. It's the only way to work it out. So if we got here, we got the dice 1 to 6, the other dice 1 to 6, and you just simply 1 plus 1, 2, 1 plus 2, 3, and you just keep adding the results. In a GCSE, they would never ask 2 dice. Normally it'd be a coin and a dice, or 2 spinners, or something like this. The reason they wouldn't ask 2 dice is because it takes so long. Okay, number 1, factor of 12. Okay, so let's do over here, factor of 12. Well, what are the factors? Well, 1 goes into 12, 2 goes into 12, 3, 4, 5 doesn't, 6, and obviously 12 goes in as well. So that's all the factors. Now, we know with the probability, it's going to be out of 36 because it's 6 times 6, or you could count all these, is 36 options, and a factor of 12. Okay, 1 doesn't exist. 2, you have one of the 2's here. 3, yep, 2 of the 3's here. 4, yeah, these ones here. 6, okay, so you got 1, 2, 3, 4, 5. And 12, 1 here. So you just add up how many of those results you've got. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 36, divide top and bottom by 12, and you have a third. Okay, a total of 13. Well, the max total is 12, so there's no total, so the probability is 0. That is impossible. Total less than 5. Okay, different color, less than 5. So you've got 1, 2, 3. All of these basically are less than 5. And that is 6. So it's 6 out of 36. Divide top and bottom by 6. And that's 1 out of 6. Okay, next one. Multiple of 3. Okay, so let's list the multiples of 3. 3, 6, 9, 12. Okay, so you've got 3, 6, so it's all these ones here, 9, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 36 again, we already know that is a third. Okay, prime number. Prime number are numbers that have the only factors is 1 and itself. So 1 in itself, 2 is a prime number because 1 and 2. 3 is a prime number. 4, nope, because 2 goes into it. 5 is a prime number. 6, nope, because 2 and 3 goes into it. 7 is prime. No even numbers are prime apart from 2. 9, no, because 3 goes into it, and 12. Oh, sorry, last one, 11 is prime here. Okay, so if we go through these, we've got 2, 3. Okay, so running out of colors. So I've got black, 2s and 3s. 5s, okay. 7s, 2, 3, 4, 5, 6. And 11s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 15 out of 36. Okay, and that is the probability of you getting a prime number. And you can't simplify that. So I want you to go to Heggerty Maths, and can you do 3, 5, 9? And you can just use this rather than drawing out again. Make a note of this. Independent events are events that do not affect each other. So they do not affect each other. So for example, if you're flipping a coin or you're rolling a dice, they're 2 events that don't affect each other, so they're independent. But for example, if it snows one day, the probability it snows one day, and then the probability you have to go into school, well, the snow could affect whether the school is closed, so they're not independent, they're actually dependent events. Now, the key thing is whenever you use this formula, like the probability of event A, say flipping a coin, and B, rolling a dice, you can calculate this probability just by timesing their two probabilities together to work out what's the probability that both of them happen. This is and A and B happen. So whenever you're asking what probability an A and B happen, you just multiply the results. But if they're not independent, you can't do this. So question 1, roll a fair dice and flip a coin. The probability of getting a free and a tail. Okay, so probability of getting a free. There's only one free, so it's 1 out of 6 options in a dice, and a tail, 1 tail out of 2. And then to calculate the probability of them both happening, you just multiply. 1 times 1 is 1, 6 times 2 is 12, so it's 1 out of 12. Okay, next one. Factor of 12. Okay, the factors are 12, 1, 2, 3, 4. We're only going up for dice, so we can stop at 6. That's everything apart from 5. So that's 5 out of 6 is the probability of getting a factor of 12. And a head is 1 out of 2. Multiply them together, and that makes 5 out of 12. Okay, this one here. Probability of event A is 0.4. Probability of event B is 0.7. They're told it's independent. What's the probability of both of them happening? Okay, just multiply 0.4 times 0.7. 7 times 4 is 28. But when I did 7 times 4, I did 4. So to make 0.44, I times that by 10. To make 0.77, I times that by 10. So times by 10, 10. I'm going to have to divide by 100, or divide by 10, and then divide by 10 again, or puts a decimal place here. So it's actually 0.28. Okay, question 3. Fair dice is rolled 3 times. Well, when you're rolling a dice and you look at all the different outcomes, it's all independent because the roll of one dice doesn't affect the next roll of the dice. Work out the probability of all these events happening. So the probability of roll 1, you get an outcome of 4, is this one here is 1 out of 6, right? An even number, where there's 2, 4, and 6 on a dice, that's 3 out of 6, and I can just write that as a half. And a prime number, so the prime numbers are 2, 3, 5, and that's it on a dice. So again, that's 3 options, 3 out of 6, so I can write it as a half. So the probability that all of these are going to happen is 1 out of 6 times 1 out of 2 times 1 out of 2. What is 6 times 2 is 12, times 2 again is 24. 1 times 1 times 1 is still 1. So it's very unlikely it's just 1 out of 24, what you would expect. Okay, the kind of trick questions on Hegarty Maths is going to be questions 4 and 5. And the reason for that is they ask you to flip a coin twice. So that seems like 2 independent events, flipping a coin. But the problem is they ask you what is the probability of obtaining a different result on each coin. Well, the first flip is going to affect the second flip result. Because if you get a head on the first one, you need to get a tail on the next to have a different result. So when it's not independent, you have to do the sample space diagram, you know, the head, tail, and all the options, and work out the probability. And when it's independent, you can use the multiplying or the fraction. We'll just call it for now the fraction method. And question 5, and this question 5, it says, what is the probability of both dice showing a factor of 12? Okay, well, you're rolling a dice twice, what seems independent, but because they're asking what's the probability of both dice showing a factor of 12, well, the first result, again, is going to affect the second result. So you're going to have to draw a sample space diagram again. So can you go to Hegarty Maths and do task 360?